I'm Harry. I was the pipeline TD and one of the FX artists for Eden this year. I've chosen to do my submission as more of like a walkthrough for the pipeline bit, just because there's quite a lot to cover, and it'll just be a lot clearer if I can kind of explain what I'm doing as I'm doing it. I'm also going to start it off by just going through a couple quick bits from that I did last semester, just to make it a lot clearer kind of where my stuff from this semester fits into the pipeline. I will label exactly what is and isn't stuff from this semester. Our entire pipeline is based around the shot tool that I made for Solaris. Since everyone in our group pretty much ends up in Houdini at some point, it just made sense to do it in here. And it's basically responsible for managing all of our cameras, plates, like everything shot related, including rendering and then scene layout inside, but I'll get to that later. So that is something I did this semester. But you can see, like, I select shot 3, and it loads in the camera and the plate. And it's very artist friendly just because it's like very simple. Like most people are only bothered with this, but it's worked quite well because it means that the animators can come in and publish their cameras, and then the comp artists can come in and publish theirs just for the different shots, and it just makes it very, very easy to sync all the assets across different software. So you can see I just select the camera, and then I can grab a plate as well, give it a little description, and then when I'm ready, I can just click publish, and it does tech checks on all the cameras and the plates just to make sure the right aspect ratio, the cameras are the right frame range and frame rate and all that good stuff. And then it begins to move all the files over to an archive that is basically version controlled and all of that. Something else it will do is it will use the plate to generate a backplate for all of our different software for like Maya and Houdini, where it converts it to a 720p PNG that's also been color converted from Vlog into Rec 709, which will be our final output for the film, just so that when our artists are doing stuff, they can see what they're doing. Now that that's done publishing, you can see that all the paths get updated to the hop archive location that they are, and you can see that the backplate has been generated. And just for comparison, this is the EXR sequence we gave it, and then now it's got a nice Rec 709 backplate that can be used in Maya and in Houdini as well. Now that those are published for the shot, we can go into Nuke and our comp artists can load it in. So this is the shot node that I've made, and you can like really quickly just flick through all of our different shots, basically. Pretty simple. So this is the one that we just published. This is shot 3, and part of that is also the shot camera, which is its own node, so you can see it's connected up here to the shot. And it's another fairly simple node where you can change the scale. Obviously, everything gets scaled by 0.01, and it reads in the camera that we just published. Part of this set of tools for Nuke is the reload tool that I also made, which basically will go through, find all of these shot nodes and shot cameras and stuff in the scene and reload them, which is just really helpful for when, say, the plate gets updated, the camera gets updated, or as I'll speak about in a minute, like renders get updated. It just goes through and basically rebakes all of those. In Maya, you can also access all of the shot stuff through this little shelf tool that I've made, and you can see, again, these are all of our shots. They've got little hover overs to tell you what they are. Go for shot 3 again. And it sets the frame range, and it will also bring in a camera with the plate already applied. In some cases, we also have this geometry that was used for lining stuff up in SynthEyes that also gets included. It gets put on its own layer that you can toggle on and off, and it's not selectable. And we just found that the animators find it easier just to see like the ground in some shots and like get an idea of the scale. When the animators want to reload the shot, they can just rerun the script, hit confirm, and it'll reload that current shot. Or obviously you can just select a new shot, say shot 16. It will set, as I say, the timeline. And now we're on a new plate. Something else that I also started last semester was the rendering side of the shot node. All of this is pretty standard stuff. It's mainly just settings that control the camera ROPs, including like shutter speed. It's kind of like rejigged a little bit just to make it even easier for artists and their groups, kind of what I think is nicer. And then obviously we've got AOVs. We have a default button that basically sets all of our AOVs to their default, which is stuff that our compers kind of always need, like cryptomats and combine glossy, but you can also clear them. And there's the LVE tagging method, so usually we do light name. And then the holdout system, which is something that I mainly did this semester, so I'll get to that in a second. Something else this does is that it's designed to have all of our assets in here, which are kind of a complete mess. You can see the lights have a bunch of random X forms on them, and it's like a bunch of random stuff, whatever the artists want to do to get it looking nice. And then it takes that and it basically combines everything really nicely into this asset layer, the lights, the cameras, all that stuff is like very neatly laid out and also composed. So I have shot resources, which is mainly kind of the camera and the lights, and then the kind of general settings, and then the asset layer, which just holds the references to all of our different assets, which I'll get onto in a minute. But yeah, that's going to kind of conclude the little refresher on what I did last semester, just to make what I talk about next a little bit more clear. Moving back to the output holdout kind of setup that I have for the shot tool, and this is mainly something I have done this semester, and going forward, everything I've done this semester. So obviously we've got like a deep toggle, but each of these basically becomes its own render, which has been really useful just because stuff like the mech is very heavy to render. It has about 500 textures on it. So yeah, you basically, up here, you can give it a little description. So this is the arm for the cyborg, which is here. And the operation, in almost every instance, we're going to do holdout. So everything that isn't selected here is going to be held out, or you could phantom them, but holdout generally is what we do. And then within this holdout, we also have the option to prune certain bits of geo, which has just been very useful for overlaying renders, and phantom as well within the holdout, which you can see is being done down here. And this is just basically what the comp artists need just to get good integration, especially when stuff is split out over so many things that when you go to defocus it, it begins to bleed out. You also have the option to modify settings specifically for this holdout. So we've got the main settings that everything uses, and then you could say, so I'll create this and then set it to XVU. So this holdout will use XVU, and then everything else will use the base holdouts. Like pretty much all of the settings here are the same as here, but it's just really useful to kind of manually override for each thing, because that's going to be a lot easier to render than this. And yeah, it just makes our renders a lot more optimized. There's also this kind of fun toggle here that I was requested for by our effects artists, which basically removes materials on the held out items. So for this arm, this stays the exact same, but for everything else held out, we worked out it was actually more optimized to remove the materials on stuff that wasn't in the render, and it just saves on the initializing stage. The thing that makes this like slightly more interesting is that rather than just removing the materials, it actually reparents it to this null material, which is an unlit surface, but it allows the objects to keep their displacement shader. So obviously, if there's some displacement on the shield here that's intersecting with the arm, if the material was removed, then the silhouette would be different to if it had the displacement. So what this does is basically remove all of like the textured bits, but keeps the displacement so the silhouette stays the same. Finally, when we're ready to render, you come to this last tab. We want to do frame range. We have the resolution. It picks up from an environment variable, but we can override it if we need to. And then there's local and farm. We check it on farm and it gets sent over. And you can see just up here actually. And these are just all the different passes that come together to form our final render that comp department can use. You can see as well, it's got the comments there just so we can keep track of it, shot, and it's all grouped together quite nicely. Something else that's kind of nice is that when you click farm render, which I won't do because I don't want to mess with what we're doing right now, it will actually go through and check what USDs have changed and what needs to be re-exported. So if the settings are the exact same, I found that it's actually quicker just to check and compare the two USDs and then only export it if I need to. So that's been quite useful, especially for stuff like the lights which are on and the camera which are on their own USD, because I found that generally people are only just tweaking settings at this point, so there's no point re-exporting the same USD over and over and over again. Another rendering tool that I made was more of a generic ROP that a lot of our generalists have been using to submit their look dev tables to the farm. And it's pretty much the same principle as a shot tool, just combined into this like more simple node. But all of this is pretty much the same, all the render settings and all of that, except you now have like paths to output, you select the camera from existing things, and it's kind of like a Karma ROP and USD render ROP kind of combined into one with some extra features. One of those being like you can see that it like tries to clean up the stage as much as possible of stuff it doesn't need. And then we also have things like M-Play monitor, flash frames for the export, and Discord integration, which I'll get onto in a little bit. It also has the same kind of caching stuff that the shot tool does, with the options to clear the cache, and then obviously local render, farm render, and you can also cancel the render from the ROP as well, which is just kind of nice to have. When you submit to the farm, it does all of the caching of the USDs in the pre-job, which basically just speeds up, means that you can click render on farm and it'll go, and then you can leave it. So you can see 2 minutes to export the USDs, and then here they are, and then a post job just to clean stuff up and ping our Discord, which as I said, I'll get to in a minute. For our comp artists to access the renders that we're producing with the shot tool, it's quite similar. Oh, and this is a perfect example of when our shot order changes, we give them options basically. I'll just adopt a new range, and you can see there, it's now shot 15, not 18, and that's changed. But it's pretty similar to the camera shot tool, which I've already shown from last semester, where if we go down here, there is the new shot render tool as well, which basically just has all of the versions of a render and then all the passes. So you can see it's just very easy just to grab different ones from different versions. You can go back, select the first version, you can see without materials, and then update to the new one. And this is also responsive to the reload tool that I've also shown off. So it's a lot easier for them to reload things as they get updated. This workflow also supports deep. So for shot 9, which is the bore, I think in some shots we are using deep, or the comp artists are using deep. So place it down, select version, deep, and it goes this color to kind of signify that using deep, and it switches over for you. And then just to prove that that is working, you can see there are the deep points of the bore. Something that's been particularly useful this year is my farm render submitter. So you just select your right node, it asks you to save, and then it's got a toggle here that I was asked to put in just because our new artist kept rendering their proxy script, and you give it a name. And then it also asks if you want to send stuff to Discord. Something that I'm very proud of this year is my Discord bot integration, the hotbot. Basically, every tool that I made pretty much has options to send updates to Discord for rendering from Nuke or from the shot node in Houdini or the Karma ROP, asset publishing, disk cache, like anything like that. And it just has meant that we've got a whole log of everything we've done on the film. So you can see here that animation's being updated, the shot was updated, Nuke also provides this, which is like a little preview of what you've actually rendered out, which is really useful for like overnight ones. You can check it in the morning, and it basically just creates a little preview and puts it on my server, which is publicly hosted, which means that we can like check it on our phones, check it whatever, and it really helps people get crit and keep everyone up to date on like where the film is actually at. You can see here actually as well, it will give us error messages if stuff breaks, and yeah, it's just really useful. Something else that's pretty cool is that the shot tool will also provide a little preview of our renders straight from Karma. So this is quite useful just because we've got multiple holdouts, so the arm is on one, the head is on the other, but it takes them, it composites it together as best as it can with the backplate, and it also puts it in the Rec. 709 color space for us to view properly, resizes it to 720p to save size and bitrate, and then again it gets hosted. And it's just really useful so we can see if like stuff lines up, how the texture's looking, and how it sits before comp even gets to it. This year, I've also made a couple of kind of utility nice-to-have nodes. The first one is the subdivide node, which has been reused like all over our film. The thing that makes this nicer is Lucy, it's its own node. It makes it really easier for the generalist just to pop a subdivide down. Secondly, the selection is a lot easier. It removes stuff that you can't actually put a subdivision on, so like materials and stuff, like they don't appear, so all of this. And then thirdly, it's kind of nice because I can select the topmost thing and it will propagate down to the other meshes. You can see there's no actual change in there. And you can see the subdivision is still set even though I didn't actually select it. And I just found that makes it a lot more intuitive for our artists. Another nice to have node that I made this year was the materials node, which is basically the material library and assigned material that's bundled into one because, you know, we're always using those together. But you dive inside and you make your materials as normal. And then this is where like it sits in the scene graph, all your materials will go. And then yeah, you can just assign as many as you want. There's a toggle for animated. You can select an existing primitive if you want, or it will make one for you. And then you just select your materials. Again, like the subdivide node, it's quite nice because it just filters out what you can and can't actually select for this. And as with the subdivide node, it assigns it to the proper primitives as well. So it just reduces any like kind of mess ups or anything that artists might make. A node that I kind of made by accident is the Prim.Mat Restructure node. And what it does is it takes very complex assets like this, which is made up of nearly 6,000 primitives with, you know, a bunch of materials. And it basically takes the input and groups everything based on the material that's actually assigned. So you can see that anything that doesn't have materials gets left at the top under the parent that you set. So I'll call this the mech. And then all of these underneath will have the material that it's named. So all of the geometry that has the cable material applied will get this. And then it just makes it a little bit easier to see like what you're doing, like how you're working and stuff. It resolves the transform, so visually nothing changes in the viewport. It is literally just kind of an organization thing that could be useful for like look dev passes and stuff, or just to kind of understand like where your different materials are and what is actually being like pulled in. Another kind of nice to have node that the generalists asked me to make was this mesh checker, which basically just gives them an idea of the topology of their model. Basically, it takes any input and it groups it into n-gons, quads, and tris, and color codes them. So red are n-gons, green is obviously quads, and then there's yellow for the tris. And right now we're viewing the error map, which allows you to dim down the transparency, which lets you kind of see stuff inside. So you can see it helps you find errors in your mesh. And if you middle mouse, it gives you a little bit of a rundown on the point counts and stuff, what your mesh is actually doing. And then for an even clearer view of the errors and the problem places, it will just prune out any geometry that's quads, and you're left with the yellow tris and the red n-gons, which has just been, I think, a little bit helpful for the modelers to diagnose like where there might be issues in smoothing and stuff. Each asset in the film gets broken down into 3 branches that layer on top of each other to create the final asset that we render. And it starts with a main asset, which is generally what the generalists were doing, and that's made up of primarily a model and a material. And then the animation branch, which is made up of just animated geometry, which I represented with green there. And then the effects branch has options to publish for animated models, static models, and materials. So it's kind of like a final override of everything, and each branch is version controlled, and the animation and effects ones are contained within the shot override. So each asset that gets rendered is comprised of the main branch, which is used through every shot, and then each shot has its own animation and effects layered on top to produce the final model and the final material. In practice, that is done by our asset publisher node that I wrote. So you can see in instances here, like the mech, where the structure is very, very complex with a lot of transforms, a lot of materials. The asset publisher basically simplifies that all down. So you start by selecting one of the assets that we already have. I add to a database for people to access. It then resolves all of the materials, transforms, relationships, pretty much everything down, and then restructures it. So you can see here that all that geo, very messy geo, gets kind of neatly tidied up and put into the geo container. Materials, the same, also come into this, as well as pruning out unused materials. So materials that aren't even assigned because we don't want to waste space. And then there's also the option to generate a proxy. So you can see here, proxy is 120 FPS, well, above that in the viewport. Without it, it is significantly heavier and also just doesn't render properly. So at the very least, it's like half as slow without the proxy. And then I just included some nice options for the modelers to kind of choose a color. They can choose the quality of the proxy to get more and more detail, as well as a different version with the convex hull, which basically just smooths everything out. Again, still keeping it nice and clean, and that's particularly useful when there aren't a lot of individual objects like the bore, just to keep it still looking like representative of what it actually is. And then on top of that, I have also got the error view, which is kind of the predecessor to the mesh checker. And again, it's just so that the generalists can kind of see like what is and isn't wrong with their model. And this gives them an idea before they publish of what they're actually going to be pushing into the pipeline. So you can see here n-gons and tris, not to expose my friends. And then on top of that, we've got subdivide, just because we notice a lot of people are forgetting that, and then the actual frame that we want to publish. By default, the asset publisher publishes to the main branch, but obviously we're going to want to override per shot and add our own effects or animation, or both on top. So as I said, the main branch only publishes geometry and materials, and the geometry has to be static because this will be picked up in every shot that this is in. But then say for shot 15, we override it, and then we can create an animation override, and that will unlock the ability to publish frames. So you can see it down here, this has been unlocked. But the difference is that the material will not be published because there's no instance where the animators will be assigning materials or anything like that. It'll get picked up from the main branch. On the other hand, effects, they can publish materials. So for instance, if we had some smoke coming off the mech, we'd want to assign a material for that, but we could leave the mech alone and that would still get picked up from the main branch. But for another case, we have a missile impact the mech and we wanted to add like some smoke, like a burnt charred texture over the breastplate, I guess, of the mech. It was really useful that we could do that in the effects layer. So just for that shot, it had the charred material that layered on top of the main. And effects can also obviously publish animated geometry as well. And it's just been very useful throughout the entire production, just to be able to have each department publishing their own assets without having to go back and forth. So effects didn't need to go back to the generalist and ask for the materials for the model that they're simming and that kind of thing. And it just meant each one is version controlled and we can go up or down, everything layers perfectly together, and it just keeps everything really clean. Once an asset has been published, it's really easy to render. We just bring it into our shot node. It will automatically pick up what shot we're working on in this, or you can just select from the drop down. And then once you've done that, it will display what possible assets there are for that shot, which really reduces the amount of confusion and stuff by reducing clutter in the UI if there isn't an override. And you can see the proxy works really, really well. It's very smooth to run, which makes it easy to work with, especially in instances where we have really, really heavy assets. And then you can see on the asset library the different layers being loaded in. So you can see here, we've got the smoke proxy as well, which is quite nice. So for the soldier, if we wanted to just look at just the main asset, this is just the main asset with just the materials and proxies and geometry, of course. But we could also go back to version 1 where everything is version controlled, or we could add the effects layer on top. So it's really like very customizable and you can select which layers are loaded and which aren't. Generally, we leave it on the latest version. And then each thing is basically a different version. So you can see here, we've got the main branch, and then this is the animation branch. All of these are variants that are payloaded in. So even though Stage is aware of them, they're not actually loaded. Which makes it really easy to iterate and like quickly see what is and isn't being loaded and which versions. And it just keeps everything really tidy, and it's made it really, really clean and easy to render. Something else I implemented into the asset publisher is the hashing of textures. So although it's a bit of a pseudo hash because it takes way too long to hash all the 4K textures in this film, but it generates this hash string based on the last time the file was edited, the amount of textures, stuff like that, and it generates this hash, which can then be compared with a database that it keeps up to date with all the textures in our film. So we have 236 right now. And if it finds a match, it will then pull out the actual file path and use that. So you can see here, even though the Cyborg is using version 26, it's actually using version 12 of the texture because it's already converted the texture into RATs and synced them to the archive. So we can just pull from there, which has been really useful in speeding up our publish times because it doesn't need to export every texture every time. And also cuts down a lot on file sizes because we're not re-exporting arbitrary textures. I also took the decision this year to convert everything to RATs just because I noticed that when rendering, Husk would convert every texture to a RAT anyway, so this just saves on render time as well. The final lots-based utility node I made was the time prune node. An issue we were having was that assets would basically display geometry that, even though it exists at one point, shouldn't exist at that exact moment. So you can see here with this missile that basically comes in really, really quick, especially these later ones only exist towards the end to add that extra little bit of detail. But the problem is that they're getting displayed way before they should because it interpolates to that frame. So you can see here, even though the missile is here, all of this is still left over. That's where the time prune comes in. So you can see immediately it's pruned out these volumes, and it basically looks at the time samples it has, and if it's out of range, it just prunes it, which is super, super useful because it stops us needing to individually go and prune stuff at specific times. So you can see there that the missile impacts, and then this gets pruned out because it's run out of time samples. And it's been something that we've used in pretty much every shot. I also made an asset library for SOPs, which is very similar to Lot 1 with a couple more features. Almost all of our scenes start off with it for this film, for the effects people. So you start by selecting the shot that you want to work on, so you shot 32, and then it displays the relevant assets for that shot. I'll go with the mech, and then whether you want to bring the render or the proxy, whether it's static or animated, by default it's just the beginning frame. And then you've also got all of the different versions for all the layers. I'll just like show the main one, and you load it in, and it comes in packed, but you can also unpack it to get all the primitive information. You can also select the actual prim bars you want to bring in as attributes. Usually it's like name and P scale, and you can see that those have been brought in. And you can also bring in specific groups and stuff that gets converted over from the USD, and that's kind of how we've been doing all of our stuff. You can also see that I have a shot camera tool as well that kind of goes along hand in hand with this. Again, very simple. You place down the shot camera, and then you select your shot. So I'll just select it, and you can see that the backplate is already there. You can also scale the camera, but obviously usually it's going to be 0.01 because it's coming from Maya. And I also added a frame offset. So you can see it looks like it's animating. And that's basically just because we had certain shots where people wanted to do them all in one take, even though in the edit they weren't next to each other. So we can offset them back and forth. Disk cache is another node that I developed for SOPs over the semester. It's pretty much my version of the file cache, just with some certain extra features that make it pretty useful. So you can see it's green here, it's loading from disk, this simulation. The thing that makes it great is that it's got really easy versioning and pathing where you don't need to think about it. So I can version up, and now it's reading from the scene, and it'll go yellow to show that you're not, and then I can version down. And we've got VDB, BGO, all the standards. You can see in here, like everything gets saved as a version. So it makes this file path, and then within that it has the different versions. You can also choose different attributes to save it in and out, and the groups of like what you actually want and what you don't, which I find personally very intuitive because it stops people from accidentally writing out a load of attributes that they don't need. Also, when it's not on the farm, as in it's in a graphical interface, it will also cache whatever it's read in as well, which can make it really, really quick as well. When it comes to putting it on the farm though, we have the Discord button, which will send Discord updates to our server, and simulation, which if it is off, it will distribute it on all the blades, which is really useful for when we have like something fairly light, but we need to just get done really quickly. So as a demonstration for that, I'll quickly version up, simulation off, disk, and on the farm. Then it will ask you to put in a name, so I'll leave that. And then it will save the scene and put it on the farm. Now that it's on the farm, you can see that it has been distributed on all the blades, which is super helpful, as I say. You can also cancel jobs from within the node, as well as delete versions, which is super useful because it means you don't need to go mucking around with actual file paths. A secondary tool I have for this is the farm cache tool, which allows me to select multiple disk caches or anything else that writes information out in Houdini and put them on the farm. So here I've selected, I think 5, and then I can run farm cache, and it will work out the order in which it needs to go. All of the nodes will be put on in one group. You can see here, all of these are dependent on each other and won't start until the previous one finishes, which is really useful in cases like this where you've got a bunch that are chained together. Another more utility-based tool that I did create over this semester was my own version of the Labs multi-bounding box tool. I found it very, very slow, as you'll see, for what it's actually doing. It basically cuts up bounding boxes into the provided segments. As you can see, that took a couple of seconds. This is my tool called Slice, and it does it nearly instantly, the exact same parameters. My reason for creating the Slice tool was because of this Lewis Taylor talk from last year where he talks about resampling volumes based on the camera, which was really interesting and led to the creation of my Smart Voxel tool. But our film is full of a lot of smoke effects, so I made this. You basically give it a camera and it works out exactly what voxel count is needed for the render to not be noticeable, for you to not see any voxel count. So right now we're just outputting the attribute, so this is what it thinks. But you can also slice it up using the slice tool internally, and this way it will slice it into 4. So right now we're just looking at the attribute created, but we can look at the slices. So here you can see the 4 slices that it's created, and then the voxel size it's recommending for each slice. So if we visualize the voxel size, you can see that here it's a lot higher than there, with the camera viewing it from over here. And obviously you can cut it any which ways depending on the shot. Generally, it was recommended that pixels per voxel be between 2 and 3, which is what most people can't tell the difference between. So what that means is that for every 2.5 pixels, it gets 1 voxel. And then the distance calculation, whether we want it on primitives or on the points. And then there's also the option to resample, in which case it takes the input volume and then resamples it to what it thinks is the correct voxels. So you can see here actually that it's, despite being what I think is about 70 million voxels less, it actually looks better. You can see here that this is actually a lower resolution than the input, but from the camera you can't even tell. And then here it's a higher resolution because it's closer. And we've used this pretty much on all of our shots that involve volume just to keep file sizes down, keep it optimal.